Okay, last talk. Welcome. I know, a bit late. You're already tired. You're ready to go home, but I hope I can keep you awake at least for another hour. As he already said, I'm Sebastian Damm, working for sipgate as a voice VoIP engineer, and I started there at 2006. So have seen quite a quite an evolution of our voice VoIP setup, and part of my job is to monitor the voice VoIP systems too. And right now I'm nervous as hell. Yeah, and why am I standing here? Because we had quite a few times, and most of you know that situation where a customer knocks on your door and says, "Hey, my service is not working," but you look into your monitoring system and you don't see anything, and then you dig into the system and you find out that the service really isn't working, and after that you ask yourself, okay, how could I detect that earlier the next time so my customer doesn't bug me? And yeah, that's I've collected the systems that we use and that we monitor and how we monitor them. First of all, sipgate. I know some of you know what we do, and I've met some happy customers, haven't met any unhappy, and I'm going to run after the talk real quick so that that stays the same way. But we are a SIP service provider, voice over IP, and are based in Düsseldorf. We started our business in 2004. First with the German product, and later in the year with the UK product, and first started with a private customer product. And we were actually the first voice over IP provider in Germany with an offering independent of the internet access. And when we were doing business for private customers for a couple of years, we thought, okay, that market is about to be filled up, and we have to change our strategy and offer something for the business customers as well. And so we started building a hosted PBX solution, and so our goal is that you don't have a PBX in your office anymore, but instead we do the PBX and you only have the phones in your office. And 2 years ago we added some mobile stuff to it. And we are a full MVNO in the E+ network, and so we can do some fancy stuff and integrate the mobiles into our infrastructure and like make the mobiles feel like a normal extension of your PBX. And we did that, and of course have a private customer product in the E+ network called SimQuadrat. Nice word. Yeah, that's what's a bit special about us is that we do everything in-house. So we don't have a call center in Romania or a development part in China. We do everything from the front end to the back end, and also the voice over IP systems in Düsseldorf. And we have a strong focus on using open source technology. So whenever it is possible, we do use open source technology. We just hate black boxes. And of course, for the voice over IP system, that is true too. So those are the systems that we are using. You see a lot of Asterisk servers. We use them for gateways and to enable call features like conferencing and like recording and all that bonus features for our customers. Then we have Kamailio. That's the main entrance point for our customers. So their SIP devices talk with our Kamailio service, and that's actually the main routing logic in our network too. The youngest member of our setup is Yate. I don't know how many of you have heard of it, but it's a pretty powerful soft switch, and it aims to replace traditional soft switches like Telus or from Siemens, the what was it called? EWSD, yeah. And we use that for that purpose, like when we have to convert from voice over IP to traditional telephony, and also for other special purposes like fax. Oh yeah. That's what we think every time a customer calls for that too. RTP proxies, yeah, they just do what the name says. They relay the audio streams from the customer, especially from those who are behind the NAT routers, to our systems, and enabling the voice coming through. The last one is actually not a system, but it's a pretty important part when monitoring it. ASR stands for answer seizure ratio, and it's the percentage of answered calls with respect to the total call volume, and you can get quite some metrics out of that. Of course, our monitoring systems are open source too, and we have 2 Icinga servers. Why it's 2? That's some grown historically stuff. I think when checking out Icinga 2 or something like that, or Zabbix or whatever our choice will fall on, we will eliminate one of the servers. And we have almost 1,000 hosts in there, and more than 5,000 services. And there's one policy that's no checks using SSH. So we have to find ways to monitor stuff without SSH connections. And right now we are still not using any traps. All we do with SNMP is active queries, but that's probably only because we haven't really needed it until now. We use Cacti, and there we graph performance values from our backend daemons. We query them via JMX, and for telephony stuff, we graph a lot of things too, like user location, or how many channels are in use, or what's the ASR for a specific carrier, and all that. And Observium, yeah, you probably heard of that too, and we graph our network traffic there. Okay, let's start with monitoring. That's the most obvious thing. Of course, you have to monitor zip. For that, we have a simple Perl script. I think we found it somewhere. I know there is a check zip on Nagios Exchange, and we probably took that, but it was already there when I entered the company. I don't know exactly where it came from, but we adapted it to our needs and added some stuff. We haven't added TCP and TLS, but I actually wanted to do that before the conference, but didn't have the time. And what we found that is really important is the resolving of SRV records for the SIP servers, especially when monitoring some external partners. They sometimes do their load balancing based on DNS round robin, and if you don't do the or look up the SRV records and just monitor that one host that it resolves in this moment, then you probably might not get an outage of the other systems that they use. So what our script does, it resolves the SRV records and then does a zip check for each IP that is behind that SRV record. And yeah, watch the response code. That's something we had to learn. We monitored the systems, and sometimes, yeah, they were responding, but they were responding with a wrong response code. So like a carrier or even our internal systems, they should respond with a 200 or a 404, and we didn't notice that a 503 is a bad response code, and the system is not working as expected. So we built that into that script too. I provide a download link at the end, and if you want to use those scripts, you are free. Some of them are adapted to our needs, but at least they might help to implement your own checks. Now onto the first system. That's how a typical check of our Asterisk systems looks like. As you can see, there are a few basic host checks like the disk, the load, the memory, and especially the load in the memory you should keep an eye on, because what we've seen is that if there's a lot of load on the Asterisk system, then probably the voice quality is going down, and your customers could complain. And memory too, there are some times when Asterisk, which normally takes like 300 megs of RAM, suddenly uses like 3 gig, and you might want to see that and then restart this Asterisk. Specific checks. Yeah, of course, there's the zip check, and it tells us that's just that one IP address that is checked is online. Then there's an open files check. The Asterisk has in the past and still has quite a few bugs, and from time to time, if you have an unnormal hang-up of a call or some malfunction, Asterisk doesn't release the files, and there are a lot of pipes that keep left open, or even the UDP ports that were used for the RTP just stay open. And if you graph them, you can see, I mean, we haven't seen in all those years that an Asterisk doesn't increase the usage of those files, and so you might want to, or you really want to monitor the open files and have proper limits on them, because otherwise your customer comes and says, I can't set up a new call, and you look into the log files and you see that Asterisk has just run out of RTP ports available. The next check is the manager check. Asterisk provides an interface for sending requests there or querying some information. It's called the Asterisk manager interface. And we use that for checking some stuff. And as you can see, there's only this check right now just says manager connection established. Okay, that is not really useful, but what that check actually does is it executes all those checks. And you see those checks are passive, and we first tried executing them actively, each one, and for that we had to start the Perl interpreter, load the Perl module and all that stuff, and it just let the load on our monitoring system go through the roof. So we thought, okay, how can we do it better? And we came up with the solution of sending passive check results to Icinga, and that made the load go down again. What checks exactly are there? Yeah, the first one is one for the lazy people. And as I said, we have about 100 Asterisk servers, and when we roll out new config, sometimes we forget one system, and sometimes we even don't do it ourselves. And so there's a check that checks whether the git commit ID of the current version of the config is the one that we want. Then the uptime check, yeah, it tells us whether the Asterisk has restarted recently. We are running our Asterisks with daemon tools. So when they crash, they are brought up automatically. And since we don't see whether an Asterisk has crashed, we need the uptime for us to do that. And if somebody says newer versions of Asterisk aren't stable, they are. Yeah, the next one is the version check. That's pretty much the same as the config. We just check whether the desired version of our package that we built is installed on the systems where we want them. G729, that's a codec for transporting the audio. It's a pretty bandwidth saving codec, but you have to get it licensed from Digium, and so we have only a few channels on each machine, and we built that check-in just to see whether we are running out of licenses and have to upgrade them. And the last one you see here is the zipchan check. That just checks how many calls are running on the system right now, and then you can define an upper value for an alarm, and you can also define that if it's empty, then then an alarm should be raised too. Because like during the daytime, in our scenario, it's an unnormal scenario that a gateway doesn't have any calls. There are two checks actually that the manager script can query that are not mentioned here, because or like one of them is Skype. Those of you that know our product or our business customer product, they know that we have a forwarding of regular calls to their Skype extensions as part of it. And I don't know if anybody in the world uses that Chen Skype anymore, but we do. And that's actually not open source, and you have to download a binary from Digium. I don't know if it's even available anymore, and it can be a bitch, especially after restarts of Asterisk. Sometimes the Skype channel is not working anymore, and sometimes Asterisk says it is working, but the helper application that's behind and running additionally to Asterisk is not working, and so we built in a Skype check that just checks whether the Skype channel type is working. And the other one that's not on here is DADI. That's when you have a Digium card or Sangoma card in there, and you you have plugged in regular phone lines. Then you want to know whether that line is actually up and running, and so we have a check in there that can just see whether that line is up and how many calls are on there. So as I said, we push passive results into Icinga, and that snippet just shows you how we do that. Icinga provides a command file, or actually it's a pipe, where you can send your external commands into, and that's what the script does too. It just opens that file, then prints the result of the currently executed check into that, and then closes it again. And how do we integrate that into Icinga? On the left side, you just see that active check. That's a regular check, as you probably know. And on the right side, that's the passive check. And what's special about this passive check is that you have to enable the passive checks. Otherwise, it doesn't take the results from the command file, and you disable the active checks. But nevertheless, you specify a command for checking it actively, because sometimes the pushing of the passive results doesn't work, or if the script dies or something like that, then no new check results are received, and that's what we have the freshness threshold on the bottom. And so if the last passively received result is older than 600 seconds, then we execute the manager check with a special option to check it actively. Here you see the command definition, and that's yeah, pretty much the same. On the left side you have the active one, and on the right side you have the passive check with an additional argument where you can specify which check you actually want to execute actively. As you can see, we are using memcache for the check script, because actually we use it only for the uptime check, and we compare the last result to the current result, and then this way we can find out whether the uptime is smaller than the last one. Next one. That's, as I said, Kamailio is the first entry point for our customers, and the main routing server in our network. And as you can see here, there are quite a few SIP checks, and we have on each system we have a few load balancers running, and they have an administrative SIP port, and that's why we have a few SIP checks there. The more interesting stuff is the Kamailio check, and for monitoring Kamailio and some internals of Kamailio, you can either I think you can use SNMP, but we have chosen the XMLRPC interface that Kamailio provides, and there are a lot of modules and a lot of commands that can be used to check some internal health of the process. What we currently are monitoring is the shared memory usage, because that has been around quite a long time, the possibility to monitor that. What we currently don't monitor is the private memory of each thread. But we've had it in the past that those threads were running out of memory slowly, and each one after the other. And until we noticed that something was wrong, there were already hours of decreased service. So what we actually should add is the monitoring of the private memory, but that hasn't been available up until Kamailio version 3.2. The other things that we monitor is are the TCP connections used? Because there's a maximum of how many TCP connections Kamailio can handle. So we want to get noticed when we have too many clients connected to the TCP port. And the last one is the Kamailio version again. There are a lot more, so you can monitor also the state of the dispatcher, so you can see whether a proxy that cannot be seen from the load balancer, but that's not included right now. How do you enable XMLRPC in Kamailio? It's actually pretty simple. You have to load the module, and then you have to specify a route where all XMLRPC requests are sent to. And secondly, you have to define that route. And what we just do here is we limit it to a specific IP that can query it, and then we just use the RPC command from Kamailio, and for all others we send them back 403 forbidden. And you really want to do that, because Kamailio listens to the for XMLRPC requests on the same port as it does for TCP SIP requests. So everybody that can access your server through zip TCP can also query for XMLRPC. So, and you don't want anybody on the internet to reset some hash tables or reload the dispatcher or disable a proxy server or something like that. The script we use, it's again Perl, and yeah, it's just it's using the XMLRPC Lite module and just executing a query and then getting back some result and then handling the result and checking whether that's how it is expected or not. The last system we want to talk about is the Yate, and as I said, that's a soft switch, and we are using it for our interconnections with Deutsche Telekom, or in this case it's E+. And Yate has implemented a lot of things that can be queried through SNMP. And the only thing that you don't check for is via SNMP is the zip check, but all the others can be queried through SNMP. And if you use it with some SS7 links, then you have to specify them in the configuration file of Yate, and then you can then Yate provides an additional entry in the subtree where you can find it. But the only thing we stumbled upon was because we just thought, okay, that's the third one we configured in our configuration file, and then it's the third one in the tree, and let's just do a basic SNMP check there, and everything is good. But from time to time, after reload, we found that somehow that link that we monitored there wasn't the right one anymore. And what Yate actually does there, it's not deterministic in which order the links are in the SNMP tree. So what you have to do is have an SNMP walk parse the one tree, one subtree, and then remember the ID of that element, and then go into another tree and get the result out of that. That's one thing that you can't do out of the box with Icinga and the standard checks. So we just wrote a little bash helper script around it. Yeah, and we monitored there the status of the links. We monitor the status of the link set, and of course the uptime. And for that we just actually there we have a lower limit where we say everything below 600 seconds is the link has been restarted recently. One last check that's on there is Yate also provides you with a possibility to query the status of some variables that you use in your configuration file, and that can change during runtime. Like when a link goes down or link comes back up, then this variable is set, and sometimes there are some flaws where it doesn't get the message that the link has disappeared or come back online, and then the variables that it uses in the dial plan to route the calls are not correctly, and that's why we have another check there that just checks for the variables, and only if all are okay, then this check is okay. As I said in the beginning, the ASR is can help you detect some problems in your voice over IP network, and it's the percentage of the answered calls and divided by the total calls. And actually what we monitor is the length of the answered calls too, because that can indicate a problem with the audio if those calls, they all get established, but they are really short, then probably there's a problem with the audio. And that's a completely hand-built solution in our network. Our gateways write some statistical data after every call, and so we into a database, and we can query it on the base of what carrier we use, or what the destination is, or which product, so like the private customer or the business product, and can find some problems earlier. Yeah, in Yate, we could actually do it via SNMP, and it's configurable, but in our network that's not applicable because it's on a wrong point in our network. So those were the main parts, but of course not everything. Of course, you have to monitor the RTP proxies, and those RTP proxies, they provide a UDP control port where the Kamailio talks with the RTP proxy, and you can just check whether that conversation is working. And there are actually two different ones. We're using RTP engine, and it has a new interface and an old one, and we can monitor both. And additionally, on the RTP proxies, we are monitoring the open files there too, because there were some cases where RTP ports weren't released the same way as an Asterisk, and then after a while it couldn't handle any calls anymore. Of course, we do monitor the SIP connectivity to some partners, and since we are not using an SBC in our network, but we have a proxy setup. SBC is a session border controller. That's typically a device that sits on the edge of your network, but our network is not structured that way, and so we send out all calls to partners through an outbound proxy, and that's why we have two checks for each SIP partner, and one is directly from the monitoring system, and one is through the outbound proxy. Because that could be a cause of a problem as well. Function tests, we use that right now actually only for emergency calls. So we test whether emergency calls are going through our network fine, and for each product, but we could extend that for checking whether some features work or not. Enum is used in a large part of our network for resolving like numbers to users or load balancing calls through different gateways or carriers, and that's since enum is actually only a special part of a DNS, you can query that with a regular check DNS. A couple of weeks ago, we had a case where over the night the location of some product just dropped dramatically, and we didn't notice it. And so now we are also monitoring the user location. The user location means that it's the customers that are online and registered to our service right now. And you can get them out of either directly out of Kamailio through the XMLRPC interface, or we have a little cron job running in the background that writes it into a database from the server, since we need it for our web interface anyway, and we just count the number of users there. Stun, it's more or less necessary for voice over IP, at least in NAT scenarios, and so we have a Perl script that really does a stun client request and expects an answer. And the last one on here is IP tables connection tracking. At least for our SIP load balancers, they have a local firewall, and so there are a lot of customers, as you saw on the first slide. There we have more than 100,000 or a couple of 100,000 users, and if they all send just one packet there, then the connection tracking table will be full pretty quick. And so you have to increase that value, and you have to keep an eye on whether that value reaches the limit. Okay, that's basically it. We have some of the scripts that I mentioned here. I've put behind that link. That's basically only a redirector to GitHub, and yeah, of course, we hire too. questions?
Hi. On your business infrastructure, do you set up some IVR for the receiving calls from for the call center? The IVR that you can choose, press 1 to call the support, press 2?
Yeah, actually we have added that a couple months ago. Okay,
so you don't know if you can check if some path is broken?
No, we don't have a check for that right now.
Okay. Yeah. Okay, thank you.
But that would be a function test too, and with those, since we have the framework now, it's probably not too hard to implement that. What we use there is just zip-p. That tool that can set up, or you can stress test with zip-p, but you can actually just do a real call and then send audio through and send also DTMF, and you can do it with that setup. But zip-p automated is a bit hard because it actually expects a real terminal, and so you have to run it in a screen session or something like that.
Okay, thank you.
Hallo, ich wollte fragen wegen SIP-TLS. Da bin ich auf Probleme mit den Perl-Module gestoßen. Wissen Sie da, gibt es irgendeine Lösung, dass da schon die Integration gibt für den SSL-Layer?
Okay, the question was whether the
Sorry.
No problem. Whether the Perl module supports TLS.
Yes, exactly. Behind.
Okay, since we haven't implemented that, so I don't know whether our script would or how I would implement it right now. So that's on my roadmap, probably pretty soon. But yeah, maybe you can drop me a mail and we can discuss that whenever I get to implementing it.
Okay, this would be great. Thanks.
I was interested in how exactly you monitor the SIP connections. What messages are you sending to the
we're sending option packets.
Just options?
Yeah,
okay.
Just options. And most of the systems will answer in some way. So there's haven't seen a system that doesn't answer at all. So if it's not configured, so like Yate answers with a 415, I think, method not implemented, and Asterisk answers with a 404, that's the standard response, and in Kamailio you can configure it yourself. Yeah, and for our carriers, we just check how they respond in a normal case, and then we say that this is the correct response code.
Okay, yeah, thank you.
Hi, how do you do functional tests with emergency services?
Actually, we only tested until the border of our network. So, there are some things that have to happen on the way there, and so like we have to find out the location of the user, or the location where he's registered from, and then we have to find out what the correct emergency code is for that call, and we set this and send it to the border of our network, and there we have for this user that's calling from the monitoring system, we have an exception there, and we say busy. And if it doesn't return busy, then something's not working.
Are there any other tools you're using for SIP testing, like SIPSAC, SIP-P, QAF, or?
For automated testing, no. I mean, for stress testing, whenever it is we need it, we are using SIP-P, and you probably have to build it yourself, because the versions that's common with Debian or Ubuntu, they don't have a option for authorization, and they are not linked against the OpenSSL library. But yeah, sipsec, we have used that, but that's only like when testing something, but not automated.
So no further questions. So then I want to thank Sebastian for the nice inside look on sipgate.